Elon Musk and his team at SpaceX have been tirelessly working on the Starship project, aiming to revolutionize space travel and ultimately make life multiplanetary. Recently, after the fourth test flight, Musk revealed significant changes and improvements to the next Starship prototype. These modifications are a result of meticulous analysis of flight data and lessons learned from previous tests. This detailed narrative explores the journey of the Starship development, the challenges faced, the innovative solutions implemented, and the broader implications for the future of space exploration. Elon Musk's vision for SpaceX has always been ambitious. From the beginning, his goal was not only to make space travel more accessible, but also to enable human colonization of other planets, particularly Mars. The Starship, with its fully reusable design, is at the heart of this vision. Unlike traditional rockets that are discarded after a single use, the Starship is designed to be launched, landed, and reused multiple times, drastically reducing the cost of space travel. The development of Starship has been a journey of innovation and perseverance. The initial prototypes, often referred to as starhoppers, were basic versions used to test fundamental design concepts. These early flights were not without their challenges. Structural failures, engine issues, and software glitches were common, but each failure provided valuable data and insights. One of the most significant challenges was developing a heat shield capable of withstanding the intense temperatures experienced during re-entry. Unlike the Space Shuttle, which used ceramic tiles, Starship's heat shield needed to be both more durable and easier to maintain. SpaceX experimented with various materials and designs before settling on a robust solution that could endure the rigors of repeated use. The fourth test flight marked a critical milestone in Starship's development. This flight aimed to reach higher altitudes and demonstrate controlled descent and landing. While the ascent was successful, the descent and landing highlighted several areas that needed improvement. The prototype experienced issues with its Raptor engines and landing legs, leading to a hard landing. Despite these setbacks, the flight was far from a failure. It provided a wealth of data that the SpaceX team meticulously analyzed. They identified specific weaknesses in the engine design and landing mechanisms that needed to be addressed. Additionally, the heat shield showed signs of wear that suggested further enhancements were necessary. Innovations and design changes, armed with data from the fourth flight, Elon Musk and his team set out to make substantial improvements to the next Starship prototype. These changes spanned several key areas. Engine efficiency and reliability. One of the most critical components of the Starship is its Raptor engines. These engines use a full-flow staged combustion cycle, which is more efficient than traditional rocket engines, but also more complex. After the fourth flight, SpaceX made several modifications to improve engine reliability and performance, including redesigning certain components to withstand higher pressures and temperatures. Enhanced heat shield. The heat shield underwent significant upgrades. SpaceX incorporated new materials and a more resilient design to better protect the spacecraft during re-entry. These changes aim to ensure that the heat shield could endure multiple flights without significant degradation, reducing maintenance time and costs. Landing mechanisms. The landing legs and mechanisms were completely redesigned. The new design focused on better shock absorption and stability to ensure safer and more reliable landings. Additionally, SpaceX integrated advanced sensors and software to improve landing precision. Structural integrity. The overall structure of the Starship was reinforced to handle the stresses of flight and landing more effectively. This included using advanced alloys and manufacturing techniques to create a stronger, lighter spacecraft. The broader implications. These improvements to the Starship prototype are not just about perfecting a single spacecraft. They represent a significant step toward making space travel more routine and accessible. The ability to reuse a spacecraft multiple times without extensive refurbishment has the potential to lower costs dramatically, making it feasible for more missions and participants. Moreover, the advancements made in materials science, engine technology, and software will have ripple effects across the aerospace industry. Innovations developed for the Starship can be applied to other spacecraft and applications, driving further progress in space exploration. The road ahead. Elon Musk's vision extends far beyond the next test flight. The ultimate goal is to create a fleet of starships capable of carrying humans and cargo to Mars and beyond. Each prototype and test flight brings SpaceX closer to this goal. The next steps involve not only perfecting the spacecraft, but also developing the infrastructure needed for interplanetary travel, such as refueling stations and life support systems. SpaceX is also working on integrating Starship with its Super Heavy booster, a massive rocket designed to launch the Starship into orbit. This combination will be the most powerful launch system ever built, capable of carrying large payloads to the Moon, Mars, and other destinations. Conclusion: the journey of the Starship is testament to human ingenuity and the relentless pursuit of progress. Each test flight, each challenge, and each innovation brings us closer to a future where space travel is as common as air travel today. Elon Musk's recent revelations about the changes to the next Starship prototype underscore the continuous effort and dedication of the SpaceX team. As they push the boundaries of what is possible, they inspire a new generation of scientists, engineers, and dreamers who will shape the future of space exploration. The road ahead is long and fraught with challenges, but with each step forward, we move closer to making the dream of interplanetary colonization a reality.